An electric field is a region in space where a charge experiences a force. And we can draw electric field lines around charged bodies because these field lines show us the direction of the force on a small positive charge. So it's worthwhile just making a quick note of that before we start to sketch these electric field lines in these three cases. So we can write electric field lines, electric field lines show us the direction of the force on a small positive charge. And that's the convention that we use in physics to show us the electric field lines. So let's consider the case of a positively charged point in space. Now I've drawn it quite large, but that could be just a very small point on the page. If we brought a positive charge close to it, then which way would that positive charge experience a force? Well, we know that like charges repel, so the force on that charge would be directly away from the source of the positive charge. And that would be the same no matter where we put that small positive charge. So the electric field lines for this case emanate, good word that, emanate. That means come out from, radiate, maybe there's a better word, from the center of that point in all directions. We're only doing it in 2 dimensions, but in 3 dimensions it would come out like a great big sort of porcupine. Oops, slightly wobbly line, should be straight. And that is the electric field pattern around a point charge. So that's a point charge. In this case, a positively charged point charge. What about between 2 parallel plates, where one is positively charged and one is negatively charged? Let's take a look. The positive charge we put into this region, which direction would that experience a force? Well, it would be repelled from this side, the positive side, and it would be attracted to the negative side. So it would move directly towards the negative plate. And in fact, that's the part of the field line, and the field lines here would look like this. Remember to draw the arrows on your field line because that's telling us where the force is directed. Now there are some edge effects which you don't really need to worry about. The field lines kind of do this at the edge, but the most important thing is that in the center we have a uniform electric field. Now, what do I mean by uniform? Well, if the field lines get close together, like here, it means that the electric field gets very strong. The lines are packed more densely together. And as the field lines get further apart, the electric field, and therefore the force on a positive charge, gets weaker. So the electric field lines also tell us the strength of the electric field by how densely they're packed. In this case, they're all the same distance apart, and so this is a uniform field, a uniform electric field between 2 parallel plates. What about a negatively charged sphere, such as you might find in a Van de Graaff generator? Well, let's try the old trick with the positive charge. Which way would that charge be attracted or repelled? Well, it's going to be attracted towards the negative sphere. And so you might get an idea now of we've got a similar pattern now as to the positive charge, except all the lines will be going inwards because that's the direction that a positive charge would be attracted. So we'd do something like this. And so on. Note that the lines get closer together as they get closer to the sphere, and so that means the electric field strength increases, gets a stronger force on the particle. Okay, so those are three common examples. I'm just going to show you a couple more examples just so that you are equipped with all the possibilities that you could come across. What about a negative point charge? Let's have a look. Well, using the same idea, a small positive charge would experience a force going in. And so this would be the same as in the negatively charged sphere. It's just that it's a point. We would get all the field lines going in, like that, and so on. What about two parallel plates which have the same charge? Well, this is a little bit more tricky, and the direction which a positive charge will be repelled, because it's going to be repelled from both plates, looks a bit like this. So we would have lines of electric field which would look like so. It's like they're repelling each other, and the arrows would be away. So that would be the path that a positive charge would take. And notice there's no electric field in the center. Finally, what about a sphere that's positively charged? Well, this is going to be very similar to this case here. In fact, it's going to be exactly the same, except that the sphere is not a point charge, it's just a large object. So we would have the electric field lines radiating away from the center of the charged sphere. So I hope that has made sense. If in doubt, remember your friend, which is the small positive test charge. And you can place that in different points in any situation, and the force that positive charge experiences will be the field line at that point.